Hello friends, welcome to Shiksharthi. In this video, we shall be discussing ratio, proportion and variation. So let's start. Now, this topic is a very important one, and this we generally tell it for every topic, but this is very important from the perspective of arithmetic. Now, when we talk about arithmetic, we basically mean what? We are basically talking about numbers, we are talking about percentages, fractions, ratio, proportion, variation. We are talking about mixtures, allegations, averages, mean, time, distance, speed, time and work, right? These are some topics of arithmetic. So you would see this entire session we have divided into few parts again. Now first part is we will try and bring an analogy between fractions and ratio, proportion, variation. For further discussions, R is for ratio, P is for proportion and V is for variation. Second, which is B part, we will be talking about the terminology used. Third is something that we have already talked about, is the multidimensionality of this topic. I mean, what are the uses? How is this topic used, and this topic uses which other topics? So either ways, we talked about this topic is very, very important from the perspective of arithmetic and from the perspective of other chapters or maybe broad chapters. So the topics that we talked about, in addition to those topics, topics like equations, special equations, remainder theorem, divisibility theorem, then we can talk about matrices, determinants, coordinate geometry, etc. Now in all these topics you would virtually see the usage of ratio, proportion. So we call it as a multidimensional topic. So starting off with the analogy. So now when we are trying to draw an analogy between fractions and ratio, proportion, variation, we are talking about similarity and at the same time we are talking about dissimilarity. So plus here signifies similarity and minus signifies the dissimilarity between the topics. So starting off with the first one, and then we'll talk about the terminology also used. So starting off with the first case that we talked about. Under the head of first case, the very first point here is when we talk about fractions, I've already done a video on fractions, so you may refer to the video on fractions if you have not seen yet. Even if you have seen, please see it again so that you are able to relate it with this topic. So in fractions, we talk about the numerator and the denominator. So the numerator, if I say that there is a fraction like 3 divided by 2, 3 upon 2 or 3 divided by 2. This is the terminology which is used in terms of fractions. In either of the case, 3 is your numerator and 2 is the denominator, right? Now another point which has to be understood here is in fractions, the numerator can be any real number and the denominator can be any real number except for 0. This is the main thing that we need to understand. So if you recall my video on numbers, there also I have talked about fractions. So for a fraction to be formed, all that we need to know here is the numerator needs to be a real number, any real number, and the denominator needs to be a real number other than 0, right? Okay. Now the same if I talk about the terminology used in a ratio, just for the sake of writing it down, I have written it as A is to C. Now this is to is what? I mean, is it a colon? Okay. So now this A is to C is nothing but the way ratio, proportion is denoted. Now in terms of ratio, proportion, A is known as the antecedent and C is known as the consequent. So please remember for all times to come that in a ratio you will never ever call it as the numerator is to a denominator. You are supposed to use the terminology correctly. So if I were to compare in a fraction, the numerator becomes the antecedent and the denominator becomes the consequent. This is something that you need to understand. Okay, at the same time, this is the segmentation that I have talked about in my fractions video, but just to relate it with ratio proportion. Now minus 3 by 2 and plus 3 by 2 are positive and negative improper fractions. IPF is improper fraction. Similarly, minus 1 and plus 1, I can say that this is a kind of a fraction only, wherein the denominator can be made equal to 1 or whatever. So I can say that this is nothing but a negative and a positive ideal fraction. And then I'm talking about a negative and a positive proper fraction. Now what is a proper fraction? Wherein the numerator is smaller than the denominator. Right? I hope I have made my point clear. Okay. Now when I talk about the same representation in terms of a ratio, naturally IPF becomes what? Improper ratio. IDF becomes ideal ratio, and PF becomes proper ratio. But the point to be understood here is, if I say that this is, can the ratios be negative? Of course. In arithmetic, we will never talk about negative ratios, but in other topics like coordinate geometry or elsewhere, I can talk about negative ratios. But in arithmetic, I will never talk about a negative ratio. Now, what is a negative ratio? Now, these are varieties of improper ratio wherein 3:2, minus 3:2. So you will see at a time either of them would be negative. When I say either of them, that means I am talking about either the antecedent being negative or the consequent being negative. Both of them together, if you put it as negative, naturally it becomes 3:2 only, which I have not written here, because this can be understood as minus 3:-2, or this can be understood as plus 3:2. At the end of the day, it becomes 3:2 only. Right? Similarly, when we talk about a proper ratio also there can be 3 formats. From the perspective of arithmetic, we will always talk about the positive ratios only. From other topics perspectives, we can talk about the negative ratios also. Similarly for ideal ratio. 3 cases. I hope I have made my point loud and clear. Third point. Now, can I say 1 divided by 1 is equal to 1? Yes. Can I say 1 divided by 2 in terms of fractions can be written as 0.5? Of course, I can say this. Similarly, 3 divided by 2 can be written as 1.5. But in a ratio, you can never write 1:1 as 1. Now, what is the point that I am trying to make here? The point that I am trying to make here is, in a fraction, the numerator and the denominator may or may not coexist. Now, when I say they may coexist, we are basically talking about IPF and PF. And when I say the numerator and the denominator may not coexist, then I am basically talking about ideal fraction. But in a ratio, antecedent and the consequent will always coexist. Coexist means that they will always come together only. You cannot say A is to C is equal to A. At the same time, you cannot say that A is to C is equal to C. They will coexist. At the max, what you can say is, let's see that. So if I am saying 1:2, I can definitely say that this is 0.5:1, which is just like saying this is 1/2:1. At the same time, 3:2 can be written as 3/2:1 or 1.5:1, or I can write it as 1:2/3. Right? Okay. So point number 4. Now when I take a basic fraction as 1/2, I can write equivalent fractions. Now what are equivalent fractions? I multiply the numerator and the denominator by the same number, but that same number should be a non-zero number. So for example, what am I saying here? Let us say if a fraction is n upon d, I can multiply the numerator and the denominator by the same number, but this same number should not be equal to a 0. Henceforth, it can take any other real or imaginary values. That is not the point of contention. But the point of contention here is you cannot multiply the numerator or the denominator or both by a 0. Same when I am talking in terms of a ratio, can I write equivalent ratios? Yes. So here you see a similarity. Now when I am writing a ratio, I need to remember the same. X cannot be equal to a 0. At the same time, x can be either real or imaginary. Again, that is not the point which matters here. The point which matters here is x cannot be equal to a 0. That means, can I use ratios in imaginary numbers? Of course I can, because it is a multidimensional topic. Okay, next point. So if I am saying 1 divided by 2 divided by 3, this has to be understood as 3 by 2. Let's say now this is a fraction. So now if you are writing a fractional format, at the end of the day you have to write it as n upon d only. You can't say 1 divided by 2 divided by 3 divided by 4 and you leave it as it is. But when I am talking about a ratio, 1:2:3, this is nothing but the extension of the point that we have discussed earlier. So point number 3 and point number 5 in a certain way are connected with each other. So now, but point number 3 is being taken to a next level. What is the next level here? In a ratio, now in a fraction, I know that I will always have a numerator along with the denominator. So you will essentially see that there will be a maximum of 2 entities. Now when I say 2 entities, that means I am talking about the denominator and numerator, both of them coexisting, or only the numerator exists, which is this case. Here the numerator and denominator, both of them coexist. But in this case, only the numerator exists, not the denominator. But in a ratio, if I am talking about, so here we were talking about 1 divided by 2 divided by 3, ultimately it gets converted into numerator upon the denominator only. But when I am talking about a ratio like 1:2:3, this cannot be written as 3 divided by 2. Yeah, or it cannot be written as 1:3 divided by 2, to be more precise. How can this be written as? I mean, I can divide each of them by one of them at a time. I repeat, I can divide each of them. For example, if I am saying the ratio is A:C1:C2, if this is the basic ratio, this can be written as 1:C1 upon A:C2 upon A, or I can write it like let's say A upon C1:1:C2 upon C1, or I can write it like A divided by C2 C divided by C1:C2 1. These are the 3 formats in which I can write this. Maybe in some other format also, which can be a byproduct of these formats, basic 3 formats. Based on these 3 formats, you can always write down equivalent ratios and have other sprouts as well. Okay, so please remember this. Point number 6. If I say what is the reciprocal of n divided by d, which is the reciprocal of a fraction. So in that case, you will say the reciprocal of a fraction is the numerator becomes the denominator and the denominator becomes the numerator. Keeping in mind that both of them cannot be equal to a 0 when you are looking for a reciprocal. Because if you say 0 divided by 1, the reciprocal is 1 divided by 0. That is an unaccepted form for real numbers. Right? So you have to keep this thing in mind when you are talking about reciprocal of a fraction. Reciprocal of a fraction is what we have written, n upon d. The reciprocal is d upon n. But at the same time, you need to remember that both of them cannot be equal to a 0. Same with respect to ratios. Now once you know, so these were the basic inputs, the input constraints. These were the basic 2 input constraints. Now when you're taking the reciprocal, there will be an additional constraint which comes into picture, and that additional constraint would be, here the numerator cannot be equal to a 0 and here the antecedent cannot be equal to a 0. Please remember this. So when I am talking about the reciprocal ratio of A:C, the reciprocal ratio here becomes the meaning here is the inversion of it. So the inversion here is C:A. Similarly, when I am talking about the reciprocal of this fraction, which is a compounded fraction. Why do I call it as a compounded fraction? Because I have more than 2 terms. So if somebody gives me a question like, what is the reciprocal of 2 divided by 3 divided by 5? Reciprocal of this, reciprocal. So what will you say? You know that, you can assume that this is the denominator, so this becomes the numerator. Divided by how much? Divided by 2. So this finally can be written as 3 divided by 5 into 2. So please relate, had the fraction been given to you as n divided by d1 upon d2, and if you were looking for the reciprocal of this, what do you get eventually? is what I have written here. Similarly, when we are looking for a reciprocal ratio of A is to C1 is to C2, you can use the concept of numbers here. I repeat. Now when I'm looking for the reciprocal of this, I can use the concept of numbers. Now what is the concept of numbers that I can use? Let us say the LCM. Let us say, now these are parts. Now in ratio, we call them as, I can say this is A parts or A units. This is C1 parts or C1 units, because the ratio does not have a unit. It is unitless. It is dimensionless. So you can give it any unit. Right? You can say this is 1 kg, I mean this is A kgs, this is C1 kgs, this is C2 kgs, or grams, or liters, or kilometers, whatever it is. Okay. So now what you will do is, you will take the LCM of all these parts. So when you take the LCM of A, C1, C2, the best way of taking the LCM is you multiply all the parts. This is the best way, because since these are unknowns and you do not know whether they are relatively prime or they are co-primes or whatever they are. Now before I go ahead, kindly refer to my videos on numbers so that you can combine both the topics together and make them multidimensional in nature. But coming back, so the best way of taking the LCM of any given numbers, I mean whether two numbers or more, is multiply them together. Now in that case, when I am looking for the reciprocal of this, reciprocal, and when I know that their LCM is the product of all the three. So let's say this already has A units and it needs what? Another C1 into C2 units. This already has C1 units and this requires what? The product of these two. And the third, this already has C2 units and it requires the remaining product. This is the best way to find out the ratio of two or more terms. For example, when I was supposed to find out the reciprocal for this, I could have taken this as their product, which is the LCM, and this already has A units. So I require C units here and I require A units here. This is just like saying A into C and C into A. And finally it becomes what? 1:1. So please remember, if I have a ratio R, please remember R, and if I multiply it by its reciprocal, then I should get 1 in terms of a fraction. Right? It is just like saying, we had taken some cases here. If I take a reciprocal of, let's say n by d, that gives me how much? D by n. If I multiply a fraction with its reciprocal, it gives me 1. Similarly, if I multiply a ratio with its reciprocal ratio, what is the minimum ratio that I can get? 1:1. Had it had 2 terms, if it had more than 2 terms, in that case you'll be getting what? 1:1:1. Please remember this. So this is what we have discussed. I hope I was able to convey something which adds value to whatever you know. If you think that something knowledgeable has been discussed today, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you start receiving updates from us regularly. Thank you so much. Until next time we meet, goodbye.